Sorry, I'm not able to present it in person. I had an issue with the visa, so couldn't attend. But thanks for everyone who's joined both in person and virtually. First, I'll go over the AI profile. Yeah. Uh, can you go to the next slide, please? Yeah. Thank you. Okay. Just cut the live stream. Oh, okay.
Which slide are you?
The previous one.
Okay.
Hi. Okay. So traceability and accountability has been at the forefront of a lot of new AI development right now, especially with the rise of a lot of the large language models and AI taking center stage. A lot of these big AI models, including Copilot, the ChatGPT, everything is getting sued for a lot of the copyright infringement, and there seems to be a lot of ethical violations that are coming through. So a lot of it can be attributed to the fact that many of the models that are being made public have the information that is needed to assess a lot of these things being private. Can you go to the next slide, please? Yeah, and a recent article by CISA kind of says that software should be secure by design, and artificial intelligence is nothing but software. So there needs to be something like a software bill of materials even for the AI software, because there are two things to note here. At many times, AI models are not standalone by themselves. In a complex system, AI models uh, act as a component in a software, which means that we have to kind of describe the whole software along with having the ability to describe the AI properties also, and which is what is making even the U.S. military to start thinking about AI bombs. But the problem currently is in many of the software bill of materials by themselves, they don't have all the capabilities to describe a software that has an AI component, or some details of the AI component can not be captured. So we came up with this AI and dataset profile, which I'll explain in a little bit, uh, so that all the components, the ethical implications, the datasets used, the AI specific details can be described, and the compliance issues and the vulnerabilities that are associated with it can be highlighted. Can you go to the next slide, please? So there is another aspect of SPAM which is often overlooked when it comes to AI space, is that there are several standards like model cards, not standards, several documentation methods like model cards and many other things. However, if we are to do something like identifying vulnerability or ensuring compliance at scale, we need to ensure that things remain machine readable. Only then a lot of this can be done automatically. For instance, the slide that I'm showing you is a study that was done by Stanford, where they took a lot of the current state-of-the-art large language models, and they assessed for compliance across several aspects which were highlighted by the EU AI regulation. And they did this study manually by analyzing the model cards of it. However, with a standard like SPDX having ability to describe AI profile, AI, we would be able to do a lot of these things automatically, and at least that's eventually the goal that we're trying to tend towards. And the key point that I want to convey here is we need to have a standard that captures all the required data to do such compliance analysis, and it be machine readable. Can you please go to the next slide? So, as Rose was describing earlier, a lot of the details have been applied as profiles, and we have two working groups. One is for AI, which actually meets together for AI and dataset. And first, I'll talk about the AI. Can you please go to the next slide? Okay. So just a succinct description of what AI profile is supposed to do. AI profile adds on top of the core software profile. As I was saying earlier, AI components at many times lives alongside the software components. So we have this profile that adds onto the uh, core profile. We even borrow some of the elements from the core profile. And the goal of this profile is we will enable traceability and transparency for all the components of the AI software. And one of the other important things that we have to note, particularly with AI, is that we need to also capture the process that was used to build a lot of these components. So in a final software, an AI model is deployed. So a deployed model has a lot of decisions that were made earlier. Say, for example, which data set it was used to train on, what are the pre-processing steps that were done, how exactly some of the bias was mitigated, some of the noise was addressed. However, when we describe just the software, a lot of these details are missed. So one of the core ideas in this profile is to be able to capture some of these processes too, and all the risks and the uncertainty. So in another way, we are trying to introduce elements of not only the components being described in the bill of materials, but also the process being captured, so that end-to-end compliance and any vulnerability that arises from the pipeline itself can be captured and analyzed. Go to the next slide. Next slide, please. And the so both AI and dataset profile, but for this purpose, the AI profile has four key things. Like the AI profile has properties that is specific to itself, which describes just the AI software. And then there are external property restrictions, which are, we want to ensure as much reuse as possible from the existing profiles and not really reinvent the wheel. So we have external property restrictions that describes the properties that are borrowed from the other SPDX profiles. And then we have relationships, which connects the two profiles, which connects primarily AI and dataset profile, and also AI and licensing profile. So wherever there are other profile elements that we want to describe, we use the relationship to describe them. And the other thing that we've been trying, we have also as part of the AI profile is we have both the required and the optional fields. So required fields describe the minimal set of fields that is required to describe the AI component in a SPDX SBOM, and whereas optional fields add the additional details to the profile. Can you please go to the next slide? And before I go and explain the individual fields of the profile, one of the key questions might be, why not model cards? Model cards have been used to describe a lot of the AI models in platforms like Hugging Face and many other marketplaces. But the key idea of not using a model card and and the fact that one needs to use a SBOM is that model cards have limited scope, in the sense that they only describe the AI model and not the surrounding software. And at many points in time, they oversimplify the software aspect of it, and they do not capture the interdependency across many different things. And they don't have particular fields to describe or express security and compliance or versioning. And the way that they capture environmental impact is pretty minimal. And the ethical and social implications, while they have a field to describe intended use and some limitations, they don't necessarily have fields that consider all the different aspects. Can you go to the next slide, please? So to be more specific, one of the properties in the AI profile are we borrowed the supplied by, download location, package version, primary purpose, and release time from the core on the software profile. And then specific to AI profile, we ensure that we capture energy consumption, the compliance of standards, which standards it complies to, what are the limitations, what type of model it is. The standard compliance kind of ensures that we comply to, as means we capture the standards some things comply to, and the information about training, application, the metrics decision threshold go back to the aspect that I was trying to highlight earlier, that we not only capture the details of the software component itself, we also try to capture the process that is associated with it. And more towards the properties, we capture the hyperparameters, the metric, the decision thresholds that was used on the metric. And for the to ensure that we comply with acts like EU acts and EU AI Act, and to see other aspects like what are the different uh, if the privacy information is captured, what is the criticality level of it? We have the fields like safety risk assessment, the autonomy type, is the model explainable, which is one key aspect of the EU AI Act. So these are the fields that we use to describe the AI properties. And can you go to the next slide, please? Here's a worked out example of famous large language model Llama 2. We like the problem currently seems to be that many of these for describing an AI model, we need a lot of these details which are not readily available for many of the existing AI models. But as we can see from here, we are able to describe a AI model when all the details are available, and the details can be reasonably expected to be captured. And the data set that it is trained on is expressed through a relationship to the dataset profile, and the license can be expressed as a relationship too. Can you go to the next slide, please? And at this moment, I want to bring our attention to some of the challenges and the next steps that we want to focus on. One of the key problems right now is we don't have a fully integrated SBOM where AI profile is acting on top of the software profile, and a software that describes this whole thing being fully worked out. And that is something as a community we would like some contributions around. And one of the key problems right now, which is kind of close to the model cuts problem, is a lot of the fields that we have, since it also captures process, is very textual, and we need better machine readable representations, and any contributions along the lines would be really welcome. And right now, since the profile is fairly new, we don't have a lot of tooling support that is required for automatic comprehension, automatic analysis, and support from tooling group would be amazing around this. And right now we don't have a lot of user feedback for this, and a lot steps towards uptake would really help. Can you go to the next slide, please? Okay, that was about the AI profile. I'll describe the data profile, and then my colleague Gauken would kind of highlight some community examples. And dataset profile, much similar to AI profile, is used to describe the data sets, try to highlight the different problems and the challenges that are associated with the data set. And one of the key things that we do here that is not super specific to AI profile is we try to capture the lineage and the provenance associated with the data set. A data set is data set is comprised of that is used to train an AI model particularly, is typically comprised of data from multiple different sources. And sometimes these data sets have a long lineage, as in one data set is derived from multiple data sets which was in turn collected from many different data sources. And it is important to have this whole chain being traced, described, bias in every place being noted, the vulnerabilities in every place being noted. And in addition, these data sets can live without being linked to an AI model also. So we have a separate profile which kind of tries to capture all of this. Can you go to the next slide, please? Similar to, I won't go too much into this slide because this is the structure of properties being there, which captures the dataset specific properties, the profiles, the fields that are borrowed from the core profile is similar to the AI profile, and we have a similar structure to remain consistent. Can you go to the next slide, please? And here too, there is another documentation standard or a transparent or approach, that is data sheets. And the key reason why we don't necessarily use data sheets as be all end all is the data sheets lack detailed metadata, being captured. Like they don't capture all the lineage, all these data sets that the given data was derived from, they have, like, though they kind of mention the data collection process, they don't necessarily capture the full provenance or full lineage, and they don't have specific, they don't spend any specific attention to the versioning details or the dependencies, and the privacy and security information are not fully and wholly captured. And finally, though they describe about some biases that may exist with the data, they don't have specific fields that explicitly capture all the bias or the noise information. So that is why we actually, for both AI and dataset profiles, what we did was we went through these existing approaches that are being used, like model cards, data sheets, fact sheets. And as a community, we sat through and we went through all the fields to see if they need to be incorporated in the bill of materials. And then after doing all of this, what are the fields that we're missing is something that we tried to analyze and include in the different profiles. Can you go to the next slide, please? And these are the properties that we ended up with. So in the left, I show the properties that were borrowed from the other fields, and in the right, as you can see, we have intended use. We capture the size of the data set, the noise that is associated with the data set, that might be associated with the data set. If the data was automatically collected, what are the sensors that are associated with it? And as for the process, we have the data pre-processing steps being collected, the dataset collection process being collected, and for privacy, we have capture if sensitive personal information is used, what is the confidentiality level of the data set, and what is the anonymization method used. And we capture these many different dimensions so that transparency, auditability, and traceability can be ensured. Can you go to the next slide, please? And I also want to, so on the right, it shows a worked out example of the dataset. And through the open source project, which is an LFAI project, Open Datalogy, we have right now captured over 37,000 datasets metadata using the SPDX AI profile, and it can be accessed so that now these data can be used, or these data profile can be readily used for many different compliance analysis or other to check other problems associated with it. Now my colleague Gaukan will explain some of the Oh, sorry, I forgot about this slide. So similarly, the next steps or the challenges that we want to address here is we still don't have a fully integrated SBOM which works out the AI and dataset components. And similar to the AI profile, we have a lot of the fields that are textual right now, and we need to move on from the textual field so that it becomes more machine readable. And we need support from the tooling group to be able to consume these profiles and integrate it as a part of the SBOM, and we require more feedback. And now over to Gaukan.
Oh, okay. Yeah. Should I stop sharing my screen? Okay, go ahead and share your screen on the Zoom. Okay. Yep. Oh, here, let me switch screens, I think. There we go. Okay, go ahead.
Yep. Okay. Oh, sorry. Okay. Oh, no. Oh, cancel. Can you? Okay.
Yep. Okay.
Okay. This is my first time presentation in English. I must introduce myself first. My name is Gao Kun in Chinese. You can call me King in English. And I'm really glad to see all of you here. And I'm OpenChain board members. Previously I want to give my first time to OpenChain, but I'm sorry. SPDX mini submitted earlier than OpenChain. Thanks, Kate, for giving me opportunity to presentation here. Thank you. Okay, thank you. Okay, let me start my presentation. So this is the whole presentation. We divided into 5 parts. Gobi, my colleague, he has to explain the second and the third parts. So I will talk about the issue and the challenge in the AI data license compliance, and the excellent practice about the AI data compliance and the display of SBOM in OpenEuler. I record a little video. You can see it. Okay, this is the first. Because in the AI area, it's grow very fast. You can see this market. This is the demo diagram. The UI exists the 3.1 billion, and the continue to at the CAGR of the 17%. Okay. And this is the AI is rise very fast. This is very important in this slide. We conclude the AI into 3 risk areas. The first is IPR compliance. Look at the picture like this. This is a GitHub Copilot, and the code generated by AI contains the LGPL. Because it's generated by AI automatically, contain GPL open source code snippet to users. It's it have a lot of risk for the users, and the AI generated code is not full the open source obligations. This is very important. Look at the this picture. This picture has a copyright by the commercial company, but it's opened to websites and everybody can use it. It's also the IPR compliance here. And the second is the privacy leak. For example, also the GitHub Copilot is used to obtain the data from the GitHub, and the AI generated code contains the ID card information. For example, this is the full name. You can get the full name, and it's you can find the full name of the users and the address of the users. It's a privacy leakage. It's very important in this area. The second is security. Okay, so we measure risk into the current AI data. I list it here. First is IPR compliance. The second is privacy leakage. The third is security and sensitive information. That's very important for AI area, and it's a challenge here. Okay, so face this challenge, the different governments and the organization, they know this challenge and they want to do something for this. For example, European, here is European and the Italian data protection authority state at the ChatGPT should be strict checked. When the EU supervision followed, you know this is very famous in the European, and of course in China and the U.S. government do the same things here. And okay, the conclusion is in this area is a very new area, and we must do a lot of challenge here. We must do some things. I will jump the part 2 and part 3 because Gobi just told just a speech how we contribute in the standard and how we contribute in the toolings. Okay, so this is the AI toolings detection to find the same column. You know, this is a training phase. I will translate the process for you. This is the training phase, and inject the column code here, and calculate the similar matrix is the next step. So the similar matrix, and we go to the visualization phase. We can see it on our dashboard, and we deploy here in inference phase, and they divided the data clone and the no data clone. We can recognize it, identify which one is. So this is the end of the result of the real data. You can see it. Okay. Okay, this is this is SPDX. We contributed in the FAI, and over 37,000 dataset metadata are captured using SPDX dataset profile in order to conduct license compliance and analyze the part of the open data knowledge project. This is a snapshot of the FAI Open Data Knowledge project. And so I will introduce some best practice in community, Huawei opened it. And this is my sport. It's named the Xihe. Okay, sorry. It's named the Xihe platform. What we do in this platform? Okay, sorry. Okay. So, we support the complaint user and metadata data through metadata. Share the platform. First is a sharing platform. Second is a license recommendation. And third is a dataset review. You can see the first. Okay, this is the platform of the shared data. The license risk analyze data about more than 50 dataset integration, accuracy, breakdown rights, limitation, and obligations, which improve the license ability, the capability of users. We share this. And the second, a license recommendation tools adapt the AI bombs, and it's complete with the SPDX pre-release standard yet, which can provide 9 items to check to help other obtain compliance license at a low cost. This is the process of the license recommendation. For example, you want to choose a license, we can help you in these tools. And the third is dataset review tools. This tools is assistant the online municipal foundation model platform, and the lawyer in review decide in batch and reduce data hosting risk. Okay, we supply these 3 tools and make the community more health. The risk, we reduce the risk of AI bomb. Yeah. Okay. The rules for formula and the standard extract in practice of municipal community provide feedback to SPDX standard community. SPDX 3.0 RC version, now it's 3.0 RC version. I think it adds the AI bomb in this version. I think it's will release recently. Yeah, great. Thank you, Kate. Last time, without AI bomb, we also implemented the S bomb in OpenEura community. OpenEura is OpenEura is the demo sponsor of this meeting. Yeah, I have recorded a video. I will share the video to all of you. This is OpenEura website, and you can choose the community version and the format. You can see the format have 2 formats. Is ISO format and another is SecondDX format. And this is again, this is version and the format and the mirror and the architecture. And this is the result, the dashboard of the SBOM. You can see it. This is vulnerability, and this is vulnerability change, and this is a license risk and license layout. Yeah, and you can see the different color is a different risk of the license and the vulnerability. Yeah, but it's Chinese. We will translate it into English. Okay. So this is the detail of the vulnerability. You can click into it. And this is the SBOM metadata license and the vulnerability and the dependence on the software package. You can say who depends this component, and this component depends what. Okay, this is the okay, we can find the vulnerability from backend. From the vulnerability to find the component, we can find the vulnerability in component. Yeah. Okay. I think it's all of the video. My speech is over. Thank you.